You always end up with 495?
I was invoked by our friend Wallace Stem to try to explain what's happening in that video, so let me try.
The biggest number you can with those digits, and then subtract the smallest number you can with those digits.
The first thing to notice is that the number itself doesn't matter. What matters is what digits are in the number, because you always order them from highest to lowest and then subtract from lowest to highest, and then you get the next 3 digits that are going to be the next item in your sequence. What we're going to consider is a dynamical system, a discrete dynamical system, that where you start with a triple of numbers and then you order them as 321, subtract 123, and then you're going to get the next 3 digits in the sequence. And in this case, 123 goes to 189, 189 goes to 279, 279 goes to 369, and 369 does go to 459. 459 goes to itself, so we say that that's a fixed point in this operation. Other ones like 268 or 157 are not fixed, they go to 459. As she points in the video, 459 is not the only fixed point.
Unless the digits you started with were all the same, in which case you get 0.
The other fixed point is 000, because 111 goes there, 000 goes to itself, and any other triple of numbers that are all the same, they land in 000, which is another fixed point. So there are 2 fixed points. Now, a priori, there could be other possibilities in this dynamical system, such as triples that one triple goes to the other and the other goes back to the first one, or there could be cycles of triples, but this is a finite system, so there's only finitely many possibilities of what can happen, and in this particular one, they are all going to one of 2 sinkholes, 459 and 000, and nothing else happens. There is no other types of cycles for whatever reason, just because it's a finite system. And now let me give you a sense of how you prove that there is in fact only 2 sinkholes. Suppose we have a triple ABC, order from largest to smallest, minus from smallest to largest gives me another triple which is exactly the same triple, and let's say it's CAB. Then, if you write this in base 10, you get these equations, and if you simplify, you get this equation. Now, this is a multiple of 100, and this over here is at most 100. So a minus 2c cannot be larger than 1, so it has to be 0 or 1. If a minus 2c is 0, then the equation above simplifies to this one, but a, b, and c are non-negative, so this would be negative or 0, so it has to be exactly 0, so a equals b equals c equals 0, which is one of the triples we've discussed. If a minus 2c equals 1, then you can simplify to 89 is equal to 21c plus b, but because of the constraints of a and b being digits, and they are the smallest digits in the triple, you actually get that c is 4, b is 5, and a is 9. So you get the 459 triple, which is the other possibility for a fixed point.